Hello, this is Alex Yazdani. This is a Lab 3 demo for our final project in EE533 with Professor Young Cho in the spring of 2025. My lab partners are Tim Liu and Szymon Gorski. So this week we've been working on our hardware encoder and decoder. Basically, you give it a batch of images and some random data, and it does some matrix multiplication to mask that image, obfuscate it, so that then you can pass it out of your trusted environment into a shared GPU that can do some training or activations, and then you decode the data when you get it back. So right now on the FPGA, we're just doing simple batches of 8 images, which are 8 pixels each. So very small for now that we actually have working on the hardware. So the D memory for the images is only 64 entries total. Each one is 16 bits because we're using a 16-bit floating point. So first I'll just download the bit file. And then next, we want to load instruction memory. Our instruction memory is big right now. We're planning to optimize that. There are some things that don't need an explicit instruction, but for now, this is what we're working with. So after we load instruction memory, we want to load the scaler. So this is randomly generated data. It's just used to mask or obfuscate the actual data, and then once we have that in, we'll actually load our images in. Okay, so right now, we just loaded the batch data in, we loaded the scalar data in. So first, I just want to sanity check the, this is our encoded memory. So yeah, it's empty right now because we haven't done anything. So if I just run it, stop, and dump. So this is our encoded image data, and then we can take this, and I've already done so, but I've placed it in another file just called batch2. So let's just reset, load DMB, batch2, or batch2. So we load that into DMEM, then what we can do is load the scalar inverse. Now we can just run that, stop it, and then dump memory again, and this is our decoded data. So this is what we have just for now actually implemented on the FPGA. It's pretty simple, just 8 pixel images in batches of 8. We're working on scaling that up. We know that we can do it. In simulation, we're able to do it pretty simply actually, but we're just having some synthesis issues. But we're pretty confident that by the final demo, we're gonna have this working. So just to give like a short preview, this is what some image data might look like for a 64 pixel image, so 8 by 8, and then this is what it looks like once it's encoded, and then this is once we've decoded it, we're able to fully recover it. And we have that image set, and there's one more I've been using that I just want to show really quick. This is some kind of MNIST style data, so we have 0 through 6 and then just a noise image. And then here is that encoded, and then here's that recovered. So yeah, that's about it for this demo. Yep, thank you.